Section 2.4. A person invests $7,000 into a bank account with a yearly interest rate of 6% compounded annually. So we have a few questions here. How much will be in the account after 5 years? How long will it take for your investment to double? How long will it take for your investment to triple? How long will it take for your investment to mature to $18,000? Okay. So first we're going to need our function, our equation. Since this is 6% compounded annually, remember we have, or recall, A equals P times 1 plus R to the T. Our future value equals our present value, $7,000. That's our starting value, times 1 plus 0.06, which is 1.06 to the T. Remember, if it was a 6% increase, well, you have your 100% plus a 6%, 1.06, 106%. This is an exponential growth. Because the base is greater than 1, our money is increasing. So A is find how much after 5 years. So this is going to be our T. We know T now. So A equals, our future value equals 7,000 times 1.06 to the fifth, which equals, so put this into your calculator, make sure you put the exponent in correctly. So this is going to equal $9,367.58. Now again, a question that I could ask is how much interest has been earned over the 5 years. If this is our future value, this was our present value, the difference between them would be your interest earned. But that wasn't one of these questions. Now in B, it wants to know how long did it take for our investment to double. So we're looking for our time. How long? That's our time, and we're given our future value. Double. Well, if it's 7,000 now, double is going to be 14,000. So our future value of 14,000 equals 7,000 times 1.06 to the T. And again, if we're looking for how long, then we want to solve this equation. We need to solve for that exponent T, our time. Divide by 7,000. Divide by 7,000. So we get 2 equals 1.06 to the T. Now we're looking for that exponent. Somehow we have to bring that exponent down to be able to solve, to get a T equals. So you have a few different methods. One method is to take the log of both sides. So we have the log of 2 equals the log of 1.06 to the T. So whatever you do to one side, you have to do the other. But by going to logarithms, we now can bring this, we have a property that says we can bring that exponent down. So we get log 2 equals T log 1.06. And then if we want to solve for T, divide by log 1.06. Make sure you do it to both sides. So we get T equals the log of 2 divided by the log of 1.06. So if we go on your calculator, I'm just going to clear log of 2, make sure you close your parentheses, divided by the log of 1.06, close our parentheses, and we get 11.895, or roughly 11.9 years. Okay. So it's going to take 11.9 years for this investment to double. Now if you want to check, so if we want to check that, put in our answer, so it's going to be 7,000 times 1.06 raised Now if you type this answer in and you say 11.9, it'll be close, or 11.896, it'll be closer. But if we go second negative, this ANS is this previous answer. So when we hit enter, we should get our double, our 14,000. So now if we're looking for how long does it take for our investment to triple, well again it's going to be, well that's going to be 3 times our initial amount, if it's tripling, equals 7,000 times 1.06 to the t, or 21,000 equals 7,000 times 1.06 to the t. Again, we need to isolate the exponential term, divide by 7,000, divide by 7,000, and 1.06 to the t equals 3. So now we want to solve for this exponential to find out how long it takes for it to triple. Now we could take the log of both sides. I'm not sure which method you like better. So this time I'm going to convert it. Instead of doing a log of both sides, I'm going to rewrite this as log. Now this is my base. So remember, base exponent, and this is my value. So when I rewrite this, it's going to be log of my base 1.06 of my value 3 is going to equal my exponent t. So all we did is rewrite this exponential form into logarithmic form, but now we have to be able to evaluate this. So we either have to know the change in base formula, which is log of 3 over log of 1.06 equals t. So it's log of the value divided by log of the base. Here we're converting to base 10. And we can plug it in. So it's log, so log of 3, close your parentheses, divided by log of 1.06, close our parentheses, and we're going to get about 18.85 years now. So t equals 18.85 years, roughly, is how long it takes for this investment to triple. And again, if you plug it back in, the original up here, that second negative, that answer, without rounding, you should get 21. If you type in your answer 18.85 here, then it's not going to be 21, but it should be pretty close. Now, some of you, if you go math on your calculator, math, instead of using that change in base, I'm just going to go up. Instead of using that change in base, you have this log base. And what this is going to give you any base you can plug in. If you can rewrite it, our log, our base was 1.06, arrow over 3. So now we can evaluate this without our change in base. And again, we're going to get the same answer. Okay. So some of you have that in your math, it's math A. Some of you don't, so you have to do the change in base. Or you could do the log of both sides, bring your power down, and solve it that way. If we want to know now, if it said double, triple, we could find this amount, but here it's asking for a specific amount. So now our future value is 18,000. 7,000 times 1.06 to the t, divide by 7,000, and we're going to get 18 over 7 equals 1.06 t. This isn't a nice decimal, so try not to round. The more rounding you do, the more error you're going to have. Again, I'm not sure which method you like, so I'm just alternating so you can be exposed to both. Do it whichever method you like best and check your answer. So this time I'm going to go log of both sides over 7 equals log 1.06 to the t. Again, since I have a logarithm there, I have a property that says that power can come down. Log 18 divided by 7 equals t log 1.06 divided by log 1.06. And we're left with t equals, so clear that, it's going to be log 18 divided by 7. Now I want to close my parentheses, that's log of 18/7 divided by log of 1.06, and we get 16.21 roughly if you round. So it's going to be 16.21 years. So again, if we're looking for an exponent, you're going to have to go to logarithms, whether you're using one method or another. But to bring that exponent down, we have to go to logarithms. Either rewrite it in logarithmic form or take the log of both sides so you can bring that power down. So a few more examples. The number of people who have attended the top 20 U.S. theme and amusement parks has grown exponentially from 78.7 in 1996 to 122.8 million in 2007. Predict in which year 160 million people will attend the top 20 U.S. theme and amusement parks. So again, before we begin this, we have to come up with our formula so that we can use this. Now it's 78.7. It's really million, and 122.8 million in 2007. This wasn't 78.7 people, I don't believe. So I think it was millions here and millions here, because we want these units are going to have to be the same. Otherwise, if this was 78.7, then we'd have to write all this out, moving that. But I believe this problem was in millions and in millions. So in 1996, which will be my start, t equals 0, we had 78.7 million. And then 2007, so that's t equals 11 years after 1996, we had 122.8 million. So now remember how we found the equation. Here is our A, we have that, but we also have to find our B. So this is going to be B to the 11th equals 122.8 divided by 78.7. Remember, my units are millions. So B equals 122.8 over 78.7 raised to the 1 over 11, or you can take the 11th root. B equals 122.8 divided by 78.7 raised to the 1/11th, and we're going to get 1.04128. So 1.04128 is our B. And remember, our A, that's our initial value, so that's going to be 78.7, and again that was million. So our formula, y equals AB to the t, is y equals 78.7 times 1.04128 to the t. Now again, we know this is rounded. Try not to use rounded values within your calculations, but we know that's rounded. There's going to be some error in this. But if we're looking for 160 million now, that's going to be my y. 160 equals 78.7 times 1.04128 to the t. Again, I'm looking for an exponent here, so I'm going to have to go to logarithms at some point in time. But before I do that, I have to isolate my exponential term, so divide by 78.7. So we get 160 over 78.7 equals 1.04128 to the t. So in this one, I'm going to take the log of both sides. Log, I'm just going to leave that as 160 over 78.7 equals log 1.04128 to the t, remembering that t can come down. So log 160 over 78.7 equals t log 1.04128. So I'm going to divide both sides now by log 1.04128. Then we're going to get t equals, so as we put this in, be careful of your parentheses, so it's log 160 divided by 78.7. Now I'm closing my parentheses, divided by log, and if you had that number still stored from previous, you could use that A and S button and be more accurate. Or if we don't, I'm not sure if we do, we can type in 1.04128. But just know as we type that in, that is a rounded. You could be off a little bit, but this is roughly, if we round, it's going to be 17.5 years. 17.54 years. Now if it's asking for, so predict in which year now, okay, so in which year, this isn't our answer, it's just 17.54 years, which is a roughly, so it's approximately 18 years after our starting value, which is 1996. So what year, so if you can see in the margins there, 1996 plus roughly 18 years is going to be that 2014. So in 2014, roughly, there'll be about 160 million people will attend the top 20 U.S. theme and amusement parks. But don't just solve for t. You know, if it asks for how long, then that's our t. But if it asks for in which year, make sure you answer that question. The year is going to be 2014. Our next problem, if you remember, we have a half-life. And if you remember, so here's going to be a half-life of carbon-14 is 5,730 years. So we want to know how long does it take for this to decay to 24.46%. So y equals, and the initial amount was 100% of 1/2, it's a half-life, of t over 5,730. So if you remember in sections 2.2, 2.3, we came up with this equation. Again, you could show the work if you need to. But we want to know, when will it be 24.46%? Now, because we're using 100, we don't have to convert that to a decimal. This is the percent. 100 times 1/2 to the t over 5,730. So we have to solve for that exponential. Divide by 100. And we have 0.2446 equals 1/2 to the t divided by 5,730. Now here's an exponential equation. We're looking for an exponential, an unknown power. So again, to do this, you could either use either method you want. You could take the log of both sides, or you can rewrite it. The last time I did the log of both sides, so this time I'm going to go log base. Remember, this is my base, 1/2. Here's my value, 0.2446 equals my exponent, t over 5,730. But in order to rewrite it, you have to know how to rewrite it, but then you have to be able to evaluate this, which is either going to be your change in base formula, or depending on which calculator you have. If I use this calculator and I go math, notice I have that log base, so I can type in just what I see. My base is 1/2. As I move over, I'm going to put in 0.2446 and we'll get 2.0315. Now the problem is, on my other calculator here, when I go that math button and I scroll up, notice I don't have that I don't have that log option. So I have to be able to convert it or change the base to base 10 to where I can use my log button on the calculator. So this would be log of 0.2446, close our parentheses, divided by log of 1/2, close your parenthesis. And notice we get that if you compare the calculators side by side, notice we do get that same number. Okay. So you have to know how to use your technology. Log 0.2446 divided by log of 1/2 equals t over 5,730, or that was 2.0315 equals t over 5,730. So you need to show your work, but if you're calculating from here to here because your calculator can, or here you change the base and then calculate it, or instead of doing this you took the log of both sides, that's fine too. But in order to solve this still for t, we have to multiply 5,730 by both sides, 5,730. So I'm going to take that answer, notice I haven't rounded, times 5,730, and we'll get t equals, so this is t equals 11,640.5, and that would be years. Now again, if I slide this over and we do this again, so I'll start here at this 0.2446 equals 1/2 to the t over 5,730. And you can, if you don't want to see this, you can fast forward through the video, but this is log of 0.2446 equals log of 1/2 to t over 5,730. So instead of changing the base or changing from exponential form to logarithmic form, I took the log of both sides. So that allows me to bring that power down now. I have that property. So we have log 0.2446 equals t over 5,730 log of 1/2. Now I'm going to divide by log of 1/2 both sides, And now I got to calculate that, which should look familiar. It's over here. That's our 2.0315 equals t over 5,730. Multiply both sides by 5,730, and again we're going to get 11640.5, and that's years. So again, as you do this, you can look at it as one or the other, but we are going to get the same answer. If you do them correctly, you should get the same answer. Okay? But I really don't mind which method you're using as you're solving. It's whichever method you prefer. It's whichever method you're having more success with. Hopefully you understand both, and do it sometimes. Take the log of both sides. Sometimes you rewrite it from exponential to logarithmic form and then use the change in base formula. So that choice is up to you. So I want to do, here's our last problem for section 2.4. It's going to be a modeling. So notice here, let f of t be the revenue in millions of dollars from sales of a blank audio cassettes in the year, that is t years since 2000. So here's going to be our start. So if this is t, this is going to be 0, because that's our start, t years after. This is 1 year after, 2 years after, 3 years after, 4 years after our start of 2000. So use your graphing calculator to draw the scattergram. So that's going to be, we're going to have to put our data in, and if you can see it, so I'm going to go stat, edit, and I already have some data in there, so I'm going to go up and clear list 2. I'm going to go to the name, clear list 1. I'm going to put my data in, 0, enter, 1, enter, 2, enter, 3, enter, 4, enter, and in list 2, it's 162, enter, 129, enter, 98, 77, and 66. So I have my data in there, and I have to remember, for every input I need an output. So now I'm going to go to y equals. If I have anything here, I'm just going to clear it out. I have to go up to my plot. I'm using list 1, list 2. I haven't changed anything, so I'm going to hit enter for plot 1, which is my default for list 1, list 2. Then I'm going to go zoom 9, that zoom stat, to look at the scatter plot. So here's a scatter plot. We want to know if this is linear or exponential. So linear is a straight line. It's going to look coming down. But this looks like it actually has a turn in it. So this looks more exponential. So I'm going to go stat, calc, over to exponential, exponential regression, bars for variables, over to y bars, function, enter for y1. So this is going to do an exponential regression on list 1 and list 2 and store it in y1 for me. And if I want to graph it, I can see how good of a fit it was. So if I go second mode, that'll get me back to my equation. So this is find the equation. So I'm going to say it was an exponential. The equation f of t is equal to 160.06 times 0.7, and if we look at it, it's right there, 0.7936 to the t. Now, for those that have that other operating system, if I'm going to do the same thing here, zoom 9, stat calc, exponential on this one. I already have the data in this one. This is that different operating system. So there's our input list, output list. Where do we want to store it? Bars, y bars, function, y1, and then go down to calculate, hit enter. So it depends on which calculator you have, but we get the same answer. So slightly different. So here's our function that we're going to be using. Now remember, it's t years after. So it's t is the number of years after 2000, and the revenue is in millions of dollars. So it's important to understand, and this is going to be our revenue function. So it's important to understand what our unit. So if it's predicting the revenue in 2014, well, that's going to be f of 2014 minus our start 2000, which is really f of 14, which equals 160.06 times 0.7936 to the 14th, which equals, so if I go here, if I put this in, 160.06 times 0.7936 raised to the 14th, we get 6.29. So that's going to be 6.29 million. Now, remember, this was rounded, this was rounded. So if you want to see how close we are, if we go, remember our equation stored in y, so if we go vars, y vars function, y1 of, so use that parenthesis, of 14, close your parenthesis. So this is going to take 14, go to your equation in y1, and plug 14 in for x. And we hit enter. Notice we get 6.2896. It's off a little bit, but to the nearest hundred, it's still 6.29 million. If you were to go to your table, you could also scroll down to 14 and then go over, and you're going to see that answer again. So there's different ways of using the exact values that your calculator gets versus the rounded. But if you try not to round too much for these numbers, you should be relatively close over here. So now, or predict when the revenue will be 1 million. Well, 1 million, so that's going to be 1 equals 160.06 times 0.7936 to the t. Predict when, so we're looking for our time now. So we're going to have to solve this equation. Divide by 160.06, 160.06, and then I have my power, so I'm going to take the log of both sides. So it's the log of that 1 divided by 160.06. I'm not going to calculate that yet, but that equals the log of 0.7936 to the t. So this can come down. So we have log of 1 divided by 160.06 equals t log of 0.7936. So t equals, so we're going to divide both sides by that log of 0.7936. So log of 1 divided by 160.06 divided by log of 0.7936, and I get t equals log of 1 divided by 160.06, close your parenthesis there, divided by log of 0.7936, close our parentheses, and we get roughly t equals about 21 point, 6.96, or approximately 22 years after our start. But again, if you remember what our start was 2000. So this is going to be 2022 is going to be when you can see that's going to be when our revenue is 1 million. Find the approximate half-life. Well, if we're looking for the half-life, it's a half-life of our initial in our function here. Here's my initial investment, so half of that. So I want to know when it's going to be 80.03 equals 160.06 times 0.7936 to the t. So again, how did I find that? I took 160.06 divided by 2. So when we divide by 160.06, we're going to get that half, that 0.5 equals 0.7936 to the t. So again, we have an equation where we have to solve for an exponent, an unknown exponent. So we have to go to logarithms. There's no getting away from it. We could actually use our calculator, y1, y2, find where they intersect, but algebraically how we solve this, we have to go to logarithms. And I'm going to go log my base 0.936 of 0.5 equals my exponent t. So and if I use my change in base, log of 0.5 divided by log 0.7936 equals t. Now again, you could use your calculator here, you could use your calculator here. T equals log 0.5, close your parentheses, divided by log 0.7936, and we get roughly 2.998, or approximately 3 years after our start, which is going to be 2003 will be your half-life, or 3 years. So I hope that helps. Now you can look at different methods for solving. If we look back in 2322 as we go through, there'll be you could either do the log of both sides or rewrite it in logarithmic form and then change in base or use your calculator if you have that log base. But you want to go through, and make sure you can solve one method or the other. And again, hopefully you can understand both these methods and that I wasn't confusing you when I did it one method versus another. I just want to expose you to both of them. And again, you can pick which one you like. Hopefully you can do both of them. I hope this helps.